multi-stage experiments. Okay, so this one we've got independent events, but where one outcome doesn't really have an effect on another outcome. So when that's true, then the probability of A, then B, then C, then D is simply multiply all the probabilities together. So something like this. You know the game Yahtzee? Great fun. Right? You roll 5 dice and there's different combinations you have to try and get to win the game. So let's say we're looking to get the one where we're getting 4 of a kind, and ideally 4 sixes would be good. So find the probability of rolling exactly 4 sixes. Well, there's several different ways we could do it. I could roll 4 sixes and then the 5th die doesn't have a 6, and so on and so on and so on. There's all the probabilities. So the first one will be a 6 times a 6 times a 6 times a 6 times 5, 6, and then we'd add the next one and so on. And we end up eventually with 25 on 7,776. But there's a smarter way of doing it. It doesn't matter what order it occurs in. The probability is going to stay the same. So what I could have done there is just said, oh look, it's 5 times this one, because I know all the other ones are going to have the same probability of it happening. And that obviously is a lot quicker to work out. However, if they're not independent, then you actually have to go and look at each individual case and see what is happening. Like this one, for instance. 2 letters of the word lotto are arranged randomly. What's the probability that the arrangement is TO? Now, when you first look at this, you probably would do something like this, but the choice of the letters is not equally likely, so you can't do this. Probability TO, oh, well, the probability of a T would be a 2 in 5. Then probability of an O would now be 2 in 4, because we used one of the letters. So the probability is a 1 in 5 chance that we end up with TO. No, that would be wrong. Because the probability of O is different to the probability of L, for instance. So they're not equally likely. There's all the possibilities we could have. We could have LO, OL, TO, OT, OO, TT, TL and LT. So actually, probability of getting TO is 1 in 8, not 1 in 5. Okay, so sometimes we have to investigate a little bit further. It's not what you would think straight away. Ta-da!